So we're going to look now at integration by inspection. So this basically just uses the fact that differentiation and integration are the opposite to each other. So if you have something like y equals e to the 2x, we know that dy by dx equals 2e to the 2x. So when we differentiate, we get from y to dy by dx, and if we integrate, we get back to y. So in integration by inspection, you kind of make a guess at what you think the answer is going to be. You differentiate it, and then you fix your guess to make sure you've got the right answer. It sounds complicated, but once we get into it, you'll see it's straightforward enough. We'll start with exponentials then. So integrate e to the power 4x with respect to x. Now, I'm going to do probably more working out than you would need to once you get into the swing of it, but it's I want to kind of show all the working out, your whole thought process. So if it's an exponential, your guess is, well, we'll probably differentiate it something like y equals e to the 4x. Okay, so let's differentiate that. And we would actually get e to the 4x times 4. But we want to get just e to the 4x. So we need to get rid of that 4. So I'm going to multiply that by a quarter, and it would get rid of the 4. So we'll have to do the same thing to our guess. We'll have to multiply it by a quarter. So our actual answer is a quarter e to the 4x, and then remember your plus c. So if we differentiated this now, we would get e to the 4x. So our second one, 2e to the power of 3x. So your guess for your exponentials is always the actual exponential. Don't worry about the constant. So our guess would be, right, y equals e to the power of 3x. Well, what happens when we differentiate that? We would get e to the 3x times 3. But we actually want 2e to the 3x. So you say, well, what do I have to do? Well, I'll have to get rid of the 3, so divide by 3 and multiply by 2. And then we do the same thing to our guess. We multiply that by 2/3. So our answer is actually 2/3 e to the power of 3x. And then remember your plus c. So again, if we differentiate this, we should get back to our integral. Third one then, we're integrating 5x e to the x squared dx. So again, when it's got exponentials, your guess is always the exponential. So y equals e to the x squared. So when we differentiate, that gives us e to the x squared times differentiate x squared would get times 2x. So we've nearly got what our answer is over here, but we don't have 2. So I'm going to have to get rid of that 2 and put the 5 in. So we'll multiply by 5/2. So we do the same thing to our guess. We times it by 5/2. So that's our answer. Again, if we differentiate what we have here in red, we'll get back up to the integral. So 4x squared over e to the x cubed. Well, before I do any sort of guessing, the first thing I'm going to do is I'm going to bring up the exponential to the top. So it's e to the power of minus x cubed. So again, it's exponential. Our guess is going to be y equals minus x cubed. e to the power of minus x cubed. So when we differentiate, we get e to the minus x cubed, then differentiate the power, would get minus 3x squared. So that's nearly what we have. but we don't have a 3, and it's not a minus, and we'll have a 4. So we're going to have to divide by 3 to get rid of the 3, times by 4 to get our 4, and multiply by a minus. So 2 minuses would give you a plus. So then we have to multiply our guess by that. So our actual answer is minus 4 over 3 e to the minus x cubed plus c. So it's not just exponentials that this works with. So number 5, now we're going to integrate 1 over 4x plus 1 with respect to x. So you say to yourself, well, what would I have to differentiate to get 1 over something? So you have to cast your mind back and say, well, if I differentiate logs, it becomes 1 over something. So if we differentiate the log of 4x plus 1, we get 1 over 4x plus 1 times, and we'll have to differentiate what's in the bracket, so times 4. So you would get 4 over 4x plus 1. So that's nearly what we have. We don't want this 4 though. So we'll have to multiply that by a quarter to get rid of it, which means we'll have to multiply our guess by a quarter. So our answer is a quarter ln of 4x plus 1, and then remember your plus c. Number 6 then, integrate 2 over 1 minus 3x with respect to x. So our guess is going to be y equals ln of 1 minus 3x. So when we differentiate that, we would get 1 over 1 minus 3x times the differential of what's in the bracket, so times minus 3. So we don't want a minus, so we're going to have to multiply by another minus to get rid of it. We don't want that 3, but we want a 2 instead. So we'll have to multiply by minus 2/3. So we'll do the same thing with our guess, multiply that by minus 2/3. So our answer is minus 2/3 ln 1 minus 3x plus c. Our next one then, 3x over x squared plus 4 with respect to x. So what we're always looking for in these questions is that the top is the differential of the bottom or some multiple of it. So when we differentiate, like in question 6 there, something with x in it, we would get a number. In question 7, if you differentiate on the bottom something with x squared, you would get an x term. If it was x cubed on the bottom, you would get x squared on the top, and so on. And that's how you can tell that it's always going to be logs. So our guess is the log of x squared plus 4. So when we differentiate, we get 1 over x squared plus 4, and then differentiate what's in the brackets, and we get 2x. So again, I want to get rid of that 2 and get a 3 in there. So it's multiplied by 3 over 2. So that's what we'll have to do to our guess. So we get 3 over 2 ln of x squared plus 4. And remember your plus c. Question 8 then, we're integrating x squared plus 1 over x cubed plus 3x. Again, if we differentiate the bottom, we'll get up to the top. Now, there will be times, and we'll get onto these eventually in integration, where they'll look a bit like this, but it won't be a log, but we'll get onto them later in the course. So our guess is ln of x cubed plus 3x. So if we differentiate, we get 1 over x cubed plus 3x times the differential of what's in the bracket, so that would be 3x squared plus 3. hopefully you can see if we divide by 3, so multiply by a third, we will get rid of the 3's at the top there, and we'll get what we're looking for. So that means I have to multiply my guess by a third. So my answer is a third of ln of x cubed plus 3x plus c. Okay, and then just to make it a wee bit harder, you could throw in something like this, where you've got exponentials in it as well, but now it's still a fraction, it's still, the top is still the differential of the bottom. So your guess is still going to be log. So it's going to be the log of what's on the bottom, the log of a to the power 2x plus 3. So when we differentiate, we get 1 over a to the 2x plus 3, and then differentiate what's in the brackets. Differentiate a to the power of 2x, we get 2 a to the 2x. Differentiate 3, we get 0. So that's nearly what we've got there. I just realised we've got dx. But we want 4 instead of 2, so I'm going to have to multiply by 2. So I'm going to multiply my guess by 2. So my answer is 2 ln a to the 2x plus 3, and remember your plus c. So the last type we're going to look at within this integration by inspection is the function of a function one. So that's where you had a bracket and a power on the outside. So we're going to integrate here 2x plus 3 all to the power of 4. So our guess for these ones here will be 1 more than your power. So we're going to guess that it's 2x plus 3 to the power of 5. So when we differentiate, we get 5 times 2x plus 3 to the power of 4. Then we differentiate what's in the bracket, so that's times 2. So we get 10 times 2x plus 3 to the power of 4. So I want to get rid of that 10, so I'm going to multiply by a tenth. So I'll have to multiply my guess by a tenth. So our answer is a tenth upon 2x plus 3 to the power of 5 plus c. Now, when you get good at these and you kind of are in the way of them, you won't need to write everything that I've written down in blue here. You can go straight to the answer in red, but for the time being, just write out what's in blue until you really understand what you're doing. Number 11 then, we're integrating 1 minus 2x cubed with respect to x. So our guess is going to be 1 more than the bracket. So it's 1 minus 2x to the power of 4. So when we differentiate that, we would get 4 times 1 minus 2x to the power of 3, and then differentiate what's in the bracket, so we'd have to multiply by minus 2. So that would give you minus 8 upon 1 minus 2x cubed. So we want to get rid of the minus, so we're going to multiply by a minus, and we want to get rid of the 8, so we'd multiply it by minus an 8th. So we'll have to do that to our guess. So our answer is minus an 8th, 1 minus 2x to the power of 4 plus c. Number 12 then, we're integrating x upon x squared plus 5 all cubed with respect to x. Now again, don't worry about this x on the outside. We will get to questions later on where this method won't work, but at the minute all the questions that you're going to be doing are all using this method. So it's one, your guess is 1 more, your bracket to the power of 1 more than we'll have in the question. So it's y equals x squared plus 5 all to the power of 4. So when we differentiate that, we get 4 upon x squared plus 5 cubed, and then differentiate what's in the bracket, we get 2x we'll get 8x upon x squared plus 5 all cubed. We don't want this 8, so we'll multiply by an 8th to get rid of it, which means I have to multiply my guess by an 8th. So our answer is an 8th upon x squared plus 5 all to the power 4 plus c. 13 then, we're integrating the square root of x plus 3 with respect to x. So the first thing we'll do is to change that into power of a half. And then you'd say, right, well, our guess is going to be one more than the power of the bracket in the question. Just be careful with your fractions. So it's x plus 3 to the power of 3 over 2. And to differentiate then, I would get 3 over 2 times x plus 3 to the power of a half times 1. Okay, we don't want that 3 over 2, so I'm going to have to multiply by 2 over 3 to get rid of it. So I'll have to multiply my guess by 2/3. So this is actually 2/3 upon x plus 3 to the power of 3 over 2 and your plus c. Our last one then is 1 over 5x plus 3 all to the power of 5, and we're integrating that with respect to x. Now, the mistake that sometimes people make here is they see a fraction and they think it must be logs, but the top isn't the differential of the bottom. So remember, the bottom is really x to the power of 5. So when we differentiate, that would get x to the power of 4. So we're going to get a 1 on the top, so it's not a log question. So the first thing we're going to do, and don't worry, you will get better at recognizing the different techniques that you use for the different questions. Okay, so for this one here, our guess is going to be 1 more than the bracket. Now again, remember, be careful with minus signs. So it's not -6, it's -4. So when we differentiate, get -4 upon 5x plus 3 -5, and then differentiate what's in the bracket, so times by 5. So we'll get -20 upon 5x plus 3 to the power of -5. So I want to get rid of the minus sign, and I want to get rid of the 20. So I'm going to multiply by -1/20th. So I'm going to multiply up here by -1/20th. And we get -1 over 20 upon 5x plus 3 -4 plus c. Or you could tidy that up a bit and put it back into the form of the question by writing -1 over 20 upon 5x plus 3 all to the power of 4 plus c.